This is Shira Rubinoff, CEO of the Cybersphere Group. I'm here with Rajesh Patil, Interim CEO and CTO of enQase. Raj, what a pleasure to be with you here today.
Hi, Shira. It's great to be here. Thank you so much.
Oh, pleasure. So, Raj, thinking about quantum computing brings both a mix of profound excitement and significant fear, which is often described as dual use technology that can either solve humanity's greatest challenges or break the foundational security of the digital world. So, let's dive deep into this. Raj, why would you say the quantum threat, which really refers to the potential for future highly advanced quantum computers to break the encryption algorithms that currently secure global digital infrastructure, including banking, government, and personal data, and post-quantum cryptography, why is it becoming a top priority this year as opposed to any other time for enterprise CISOs and Chief Technology Risk Officers?
Great question, Shira, and it's very, very timely as well. So let's set a little bit of a context. If you think about 40 years or so, when we started using encryption, the systems were not really connected with each other. They were probably very disparate systems, and you didn't really have data leaving the boundaries of the company. But as we progressed through time, I think encryption evolved because of the sharing of information, the networking, and things were getting more and more connected. So today we're probably more connected than we were yesterday, right? So every single device, application, software, you name it, they're all connected. So as things progress, right? So we've had a great run with the encryptions like RSA, ECC, all of the ones that we've been using. They've worked out really, really well. And as you mentioned, they've been there in the banking, defense, digital identity, every single part of a digital ecosystem. We didn't really have to worry much. At no point did we ever think about, hey, listen, do I really need to be aware of anything when I'm sending information, anything sensitive over the wire to a friend or at work? We never did. And we did have a few tweaks here and there. We did bring in new algorithms, we enhanced some of them, we increased the key strength. So depending on the need and the opportunity, this was kind of evolving. At no point did we really pay a lot of attention to it because just evolution in general. But now what's happening is it's so entrenched in everything that we do. If you look at it without encryption, there's probably nothing much we can do. We cannot share information. We cannot do anything that we take things for granted. So let's go back in time a little bit. In 1994, Peter Shor published an algorithm called Shor's algorithm that if you run a sufficiently powerful quantum computer, could break the mathematical foundations that are underlying for the existing encryption. Now that's interesting, right? Since 1994, we've known this issue, that there is an algorithm that could break our encryption. But we did not really worry much about it because we did not have a quantum computer around the corner. So we're very well aware, and the existing classic computers could not break the encryption. It would just not be possible for them to do it. So fast forward 2016, I think there was a general realization that quantum computers could be a reality. They're just probably around the corner. So NIST decided to embark on a project called post-quantum cryptography. Their plan was to create a new set of algorithms that would essentially address the approaching threat from quantum computers. And the way they went about doing this is by using complex mathematics. Math so complex that even the quantum computers would struggle to break it. So that's when they started the journey. It took them 8 years to come up with about 5 algorithms, which were published in August of 2024. And that became the basis for the post-quantum cryptography. So that's the first threat that the C-level suites have to worry about. The second part to this is something called the harvest now, decrypt later. So essentially what's happening is there are bad actors all over the world stealing data right now. It's pretty useless in the current shape and form, but at some point it could be of value when you're able to break the encryption and derive and get the data out of it. So sometimes you have date of birth, social security numbers, some of the financial information, secrets, trade secrets, things like that. They are of value. So there are people spending time, effort, and money in actually harvesting this data so that they can decrypt it later and make something out of it. That's a current threat. So today that's happening as we speak. So if you really look at it, both these scenarios are impacting, risk and compliance. So if you for the CISOs and the CIO and the risk officers, this is a big risk that they need to understand. It's no longer theoretical that will quantum computers be available. It's just a matter of time. It is this entire thing. It's a structured multi-year risk management decision. It should be a top priority, and the change that we are going to propose to the encryption and the embedding of it in every single thing that we do has never been done before. So to answer your question, yeah, it's about time that we need to start looking at this very seriously. 2025 is when most of the migration process started. Organizations are looking at it very seriously across the globe because this is something you don't want to be waiting till the last minute. You need to get a head start, and there are ways to go about doing it.
Well, let me ask you this. A lot of folks say that true quantum computing and quantum risk is about 5 years out or so. And as you said, right, we don't want to be behind the ball. We want to be in front of the ball. We have to be here and now, but we also think forward and understand what's coming, but be prepared and not wait for the text and try to play catch up. That's a big mistake. So why is that urgency, as we talked about earlier in many conversations that you and I have had, why now? Why now? Why not a year from now or 2 years from now? Why is it so urgent right now?
Well, yeah, the first thing that we talk about is the harvest now, decrypt later. So that is something happening in real time. Things are happening. Is all of the data that's being stolen of value? Probably not. But as an organization, are you willing to take that risk? Number one. Number two, what happens if there's an event that pretty much compromises the security, the encryptions that we have today? Are we willing to take that risk? There's been so much thought that's gone behind it, and NIST is an amazing organization. They've done so much for us globally, right? They've put set standards, and they've taken a lot of time and effort in coming up with the post-quantum cryptography. So there is some merit to looking at it and start planning for it. The last thing you'd want to do is if it's just, let's say, 18 months down the road and you start, a process of migration. Our environments are complex. And as we talked a little bit earlier, encryption is embedded everywhere. It's integrated in everything that we do. You're talking about VPNs, servers, hardware, software, every single thing. You cannot think of anything that does not have encryption, including your phones as well. So when you look at such a big ecosystem, and it's never been done before, it's about time that we start looking at it and come up with a plan. It doesn't mean you start right away, but at least you need to have a plan in place and say, okay, this is what we're going to do. This is where we are. This is where we need to be in the next, few years based on what your priorities are. But risk and compliance needs to be really looking at it very closely.
Well said. And to the point, we talk about standards and compliance across the board. And as we mentioned, quantum resistant algorithms are what NIST is mandating. Which algorithms and what types of post-quantum cryptography would you recommend for organizations with sensitive data or valuable intellectual property to protect, and why would you say so?
Right. So NIST has come up with the PQC, post-quantum cryptography, that was published in 2024 August. It's become the global standard now. It's the de facto standard that is going to replace the existing algorithms. Now, NIST has specifically looked at something called the asymmetric algos. So those are the ones that are at bigger risk from quantum computers and because of Shor's algorithm that we talked about earlier. So NIST has come up with a couple of algorithms in the asymmetric. The first one is the key exchange, and the second one is a digital signature. Now, these existing algorithms have been there for ages, and they've worked extremely well. So NIST has come up with a newer set of algorithms for the key exchange as well as digital signature, that are quantum resistant. So this is where that we're going to adopt and then start implementing our future encryption policies around these algorithms. Now, these algorithms actually address the data in transit. So this is how the whole key exchange happens. The entire data starts moving across the pipe, and these are very, very safe. So it's a good idea to start looking at this, and the fact that NIST has published these algorithms. At the end of the day, the simple thing is both the parties have to use the same algorithm. We cannot have a mix and match of those. So having a level of standard is amazing. It's really wonderful, and NIST has done an amazing job of putting it out. So it's important to start embarking on that journey and start using these algorithms, which are there to actually help you traverse through the challenges of what's coming down the pipe. A couple more things to point out. Traditionally, we've been struggling with something called an entropy. Entropy is nothing but a measure of randomness. So the traditional approaches that we have taken have been quite challenging because the source of entropy has been a challenge. So NIST actually recommends using a good source of entropy. In fact, they do have a certification program called ESV, Entropy Source Validation, that they help you verify and validate a good source of entropy. Now, we are recommending that QRNG be used, a quantum random number generator, which provides the best entropy out there. And this makes your algorithm stronger, makes a much, much better proposition as you progress through implementing PQC, enhanced with QRNG, and a couple of other options. So just kind of getting onto the bandwagon of using the PQC as a standard and making it happen will protect everything that you have today and as well as things in future.
Well, that's certainly helpful, as there's so much out there to give direction to organizations to really understand what to look into is super important. And as we know, there's no one size fits all when it comes for anything, for any organization. And Raj, what type of timeline should leaders at large enterprises plan for to become quantum safe and crypto agile? And is the crypto agility element especially important for specific industries and also countries? And that's a big loaded question, and I'm sure you have a great answer.
Well, yes, it is. I think that's always the billion-dollar question. What are the timelines? What does it cost? So before we go to the timelines, let's talk a little bit about the crypto agility, and then we'll visit the timelines. So crypto agility has two aspects to it. The first one is for you to be agile to a point where if you need to make changes to the crypto algos in the future, then you should be able to do it very quickly and seamlessly. Today's encryptions are pretty embedded into the systems that we use. So if you're looking at a software, it has a pretty integrated encryption system in it, right? And that's true for everything else because we never really meant for this to change. We never really thought at some point in 2025 we'll have to replace our existing encryption with something new. I don't think that thought really came up. I mean, not a lot. So, so we do have an opportunity to kind of abstract it out. So you are at a point where you could just not go and replace the existing algorithms, classic algorithms, with post-quantum cryptography, but create a level of abstraction so that in the future, if you have to make any tweaks or changes to it, it's just easy. The second aspect to this is something about the sovereign algorithm. This is what you had mentioned about the countries and regions. So right now there are about 14 countries and regions, and these are in flight. It's not done yet. And they are creating something called a sovereign algorithm. Essentially what it is, it's a version of a PQC, enhancements of PQC, or just a algorithm that probably does not include PQC. We don't know that yet. As things are getting, they are in flight and they're kind of settling down, we will probably end up with the worst case scenario that will end up with multiple versions of PQC, their own version. So this creates a bigger challenge for organizations. Let's say you are an entity working out of US and you have to cater to different regions of the world. Then you need to support all the algorithms for them because they will expect you to be communicating on that algorithm. We cannot have PQC and they have some other version. So if you really look at it, this level of complexity did not exist. We did have multiple versions of algorithm early on, the crypto suite, but this is a whole different level. Number one. And the second part to that same thing is it's still evolving and it will continue to evolve. So if you really put all of that together, crypto agility becomes extremely important and you have to plan for a point where you'll have to make those changes, tweak them, enhance it, remove it, replace it. And all of that has to be done very quickly so that it does not impact your business. So that's where the entire crypto agility comes together, right? Now, let's get back to the interesting question about the timelines. Now, timelines, it depends. It depends on the complexity of the organization and all the assets that you have. Let's look at a little bit deeper. Where does your encryption exist in an organization? Today, you have it in infrastructure, your network, edge devices, you have digital certificates, VPNs, key management, including HSMs, you have software application, you have technology vendors, you have partners. And if you really look, sit back and look at it, that's a lot of places where you have encryption embedded in it. Now, when you're embarking on this journey, making yourself quantum safe and starting implementing it, then you look at those, that's quite a bit of work. So again, most of the process started around 2025, the migration. So we do not have enough data as of now to say, okay, it's going to take X number of years. But the general consensus is it could take anything between 2 to 7 years for something like this. Again, it depends on the size and the complexity of the organization. So one of the things in terms of timeline, we also look at something called CNSA 2.0. This is the Commercial National Security Algorithm from NSA. And they mandated this policy for post-quantum cryptography for national security systems. So essentially, CNSA has a timeline between 2025 and 2033. And it's a great framework for the timelines because once they have implemented it and in the process of doing that, most of the organizations and enterprises are aligning to that. In fact, Microsoft just published a few months back their entire product roadmap aligned to CNSA 2.0. So, in terms of the recommendations, we should get this done before 2030 or sooner because things are coming down and you don't want to be the last in the line to get things done. So, we recommend starting this sooner than later and come up with a plan.
Well, that leads me to the next question. Companies are always focused on their cyber posture. And certainly with the intersection of cybersecurity and AI, they're focused very heavily on that. And as we know, it exploded last year. It's continuing to do so. It will continue to do so. But how would you recommend other organizations now and get their enterprises focused on the migration to quantum encryption? How can we let the organizations know, especially as you said, we have to stay ahead of the ball, we need to be in front of it, we can't wait till it happens and then play catch up. How do we let them know that now's the time to start really getting it together to talk about the migration to quantum encryption, because what we had before is no longer secure. What we have going forward may not be secure yet unless we move it forward in a way that's going to be secure and ahead of the game utilizing quantum.
Right. So AI is making things much more difficult for the cybersecurity world. I think it's just these bots are going to make it even harder for us to secure the environments. Um, right now, our recommendation for enterprises to get started on their journey is about 4 areas that we would like everybody to focus on. The first thing is an organizational alignment. So cryptography in any enterprise is spread across, again, infrastructure teams, application developer, DevOps, cloud architect, security operations, you name it, they're everywhere. The encryption exists in everything. There's no single owner per se. Neither is a group that actually manages and owns encryption. It was never designed or meant to be that way. So the first thing that we recommend is create a cross-functional group by taking people from these organizations so they are well aware of what's happening and what the decisions are being made. And once the decision is made, the most important thing would be for all of these groups to coordinate. So you don't really want the application to be team to be ahead of the curve and the infrastructure team to be falling behind. So there needs to be a level of coordination between the different teams. So setting up a cross-functional team is very, very important. And of course, we cannot, forget the risk and compliance team to be a very, very integral part and very important for them to be, understanding on the decisions and the thoughts behind what needs to be done and when. So that's the first thing that we recommend. The second thing is, and this is very, very known across industry right now, something called a CBOM, Cryptography Bill of Materials. Essentially, what it does, it creates an inventory of all the cryptography assets that you have in the system. And again, these are everywhere. You have it in applications, API, certificates, hardware modules. You have all of these embedded in these systems. You need to really find which ones these are, where are they being used, and you have to get an inventory. So this entire exercise, there are amazing tools available out there, gives you a detailed list of data that tells you exactly your current posture, and from that you can derive your risk profile. Then once you get this data, again, going back to the first point, having an organization that's aligned to understanding and deciphering this data is very, very important because the output from this becomes an input for the next phase of implementing it. And getting the context and the ownership of this is extremely important. So this is actually an actionable data that comes out of the cryptography bill of materials. The third thing that we talk about is the suppliers, right? So you do have hardware vendors, infrastructure vendors, and they do supply a lot of hardware, software equipment to your organization. You have to start planning with them as well. Of course, they're catering to tens and thousands of organizations as well. So they would have their own timelines, they would publish it. You have to align with your timelines and look at the dependency and understand how everything kind of falls in place. You have to make sure that their delivery dates for PQC and yours are aligned to some extent, right? So that's important part of looking at your entire supplier ecosystem. The last but not the least are your partners. If you look at any bank, just as an example, you're looking at between 20 to 100 partners that they deal with. They send data, they receive data, they process the data. While you are going down the path of doing all the right things and implementing quantum resistant security, encryption, you also have to make sure they do the same thing as well, because otherwise they'll end up becoming the weakest link in that entire supply chain management. So you literally have to step back and look at the entire thing, and see where the weak points could be. Some of them are absolutely in your control because it's your organization, but some of them will not be, especially the vendors and your partners. They need to kind of align with your timelines, and you have to align with their timelines. Of course, it has to go both ways.
So it's so interesting also because it really bleeds into the whole area around cyber risk, right? It's third party risk. You're only as strong as the weakest link of your chain. Who's the weakest link of your chain? It could be a partner, it could be any human on the train, it could be anybody who's utilizing data, anybody who's intersecting with your organization. So I think that's very important that you highlighted that because there's a lot around there that people just don't understand around quantum risk and what that really means for them. And they are looking at the organizations as this is what we need to do. Once we do it, we're good. But certainly similarly to cyber risk, think about your third party, think about your partners, think about who you're collaborating with, because if everybody's not up to snuff, you're going to have issues.
Exactly. So that's where we are. I think if you look at those four areas, I think you will be in a good place to start this journey. It's not extremely complex, it's just planning it out.
Well, Raj, thank you so much. You're a wealth of information around this topic, and I certainly highly encourage people to follow you. And I'm very much looking forward to working with you at the RSAC conference, where we're going to discuss this even further and have a lot to share with our audience. So, Raj, thank you so much for your time today.
Thank you, Shira. Looking forward to the next conversation.
Thank you.